Hi, this is Jeff Spencer, Math 120 instructor for the Community College of Denver, and this is our video part 1 over section 3A, part 1. So 3A is our first section that we'll cover in the class, and it's titled Uses and Abuses of Percentages. So mainly we're going to focus on the uses, and at the end we'll show some abuses of percentages where people can misconstrue the numbers or not understand them correctly. So percentages are used all over the news and ads and things like that. So it's very good to be familiar with how they're used and how to solve certain percentage problems. So the book likes to break it down into 3 ways of using percentages as fractions. We're actually going to solve this problem here later. A total of 13,000 newspaper employees, 2.6 of the newspaper workforce lost their jobs. We can talk about it to describe change. Citigroup stock fell 15% last week to 44.25. We'll also solve that problem to figure out what it used to be before the fall. And then for comparisons. So what I like to do is basically put all the percentage problems, at least the first half of this section, into one main formula. All right, and I would write this down in your notes. This is something I would also write down on a formula sheet. Eventually you're going to be able to have a formula sheet for the test. So this is one of the main formulas I use, and how I pretty much frame half of the percentage problems that we're going to have here when we're given a percent. Okay, so remember that. If we give you a percent in the problem, then you can use this formula. The other key thing to remember is that whenever the word of is in the problem, it means to multiply. So here's our formula. We have the percent times, that's the of part right here, the original or reference value. Kind of just depends on like what makes more sense based on the wording of the problem. But either the original or the reference value equals the result, or what sometimes the book calls the compared value. So that's the formula. I'm going to I copied and pasted it to every example in this part 1. So let's say an opinion poll finds that 64% of 1,069 people surveyed said that the president is doing a good job. How many said the president is doing a good job? Well, this has the word of in the problem, okay? So this is actually one of the easier ones to start off with, because it says 64% of a number, and then they say, well, that 64% of the number is are people, are the number of people that think the president is doing a good job. So using our formula here, we're given the percent. Okay, remember in all these problems where I'm using the formula, we're given the percent. Remember, to convert a percent into a decimal, you move the decimal 2 spots to the left, or you can divide the number by 100. It does the same thing. So 64% would be 0.64. And then we take that times the 1,069, and we get the number of people saying that the president is doing a good job. If we multiply 0.64 times 1,069, we get 684.16. Since we're talking about the number of people saying the president is doing a good job, we'll round to the nearest whole person. So in this case, 684 people saying the president is doing a good job. So you'll have some basic problems where you just take a percent of a particular number. Those are definitely the easiest. Keyword is of. All right, now there's going to be some other comparison words or that we don't use instead of just of. Sometimes we have things that are more than or less than, or if we have tax is added on to the original price. So we have 2 different situations here. If we say the newer compared value is p% more than, or if we have sales tax, that means whatever percent more. The reference value, it is 100 plus p of the reference value. Now this might seem confusing at first, but just wait until we see some examples, and I'll keep writing that line in there. And then if we have a less than, or like a 25% off sale, then we would subtract that percentage off the original 100% of the reference value. So let's see how that applies. Alright, so if Carol earns 50% more than William, that's not 50% of William, it's more than William. If she makes $78,000 in salary, what does William make? Well, first of all, we should know that William makes a little less because Carol earns 50% more. But to take care of the 50% more, 50% more is the same as 100 plus 50% of, so 150% of. So I'm just kind of following the formula there at the 100 plus the 50%. Okay, So then go back to my original formula. We're not using 50% in here. We're using the 100 plus the 50% in this part right here, because my formula always uses the word of, which means to multiply. So we didn't say 50% of, we said 50% more. So you have to convert it to the 150%, which is 1.5. And 1.5 of the 150% of William's salary, that's what we're referring to. We're referring to William, is the 78,000 that Carol earns. So actually, we're not taking 50% of 78,000. We're actually going to take 78,000 and divide by 1.50 to solve this equation. If we have a number times an unknown, like a variable here, and we want to solve this, to get the value of the unknown, you actually have to divide using that formula. Okay, so a lot of these problems, eventually we're going to divide. You have to set it up so that you're going to divide. So 78,000 divided by 1.5 gives you William's salary of $52,000, which is a little bit less. And if you took 50% of 52,000, which is 26,000, and added it onto the 52,000, you would get Carol's salary of 78,000. All right, another one. A store is having a 25% off sale. Suppose you find an item, and after the 25% is taken off, the price is $45. What was the price before the sale? Well, remember 25% off, using what we've talked about before. Off is not the same thing as of. 25% is taken off, so that means we actually have 75% of the original price. So I take care of that right away. I always, if there's a word other than of, if it's more than, less than, off, then I use the 100 plus or minus to get the percentage of. Then I can use my formula, which uses the word of. So 25% off, the same thing as 75% of. So now we have 75% times the original price, which we do not know, gives you the $45. Well, to figure out the original price, you have to divide. So you take $45 divided by the 0.75, gives the original price of $60. And I forgot to put my unit in there, I'm sorry, but it should be $60. All right. So remember, a lot of times, if you think about it, if we're going back in time to figure out what it was before, those are the problems where we're going to have to divide ultimately to solve the problem. All right, let's look at another one where it's still 25% off sale. So this one says, suppose you find an item and the price before the sale is $80. What is the sale price? So now we're moving forward in time. Remember, 25% off is 75% of. So using the formula here, we're going to take 75% as a decimal 0.75. But now we know the original price. The price before the sale is $80, and that will give us the result, the sale price. So I call this the result, or sometimes the book calls it the compared value. But either way, that's the result. 0.75 times 80 gives you a $60 sale price. So let's continue. Let's say you purchase a shirt. So now we're going to have a couple tax problems here. So we'll definitely have some tax problems on the test. I want you to be able to go back and forth with tax, figuring out how much tax is, if you have a sale, or if you have a price tag, and if we have a total price, going back to figure out the price before tax. This particular problem says you purchase a shirt with the labeled pre-tax price of $21. The local sales tax rate is 6%. What is your final cost including tax? Well, tax is 6% added on, so it's like 6% more of the original value. So we have 100 plus 6% of the original price. So I took care of that 100 plus part right away. Now 106 as a decimal is, or sorry, 106% as a decimal is 1.06. And if I take that times the original value, which I know in this case, I know the original price was $21, it'll give me the total cost. 1.06 times 21 gives you 2206. So the total cost including tax is 22. I think I said 2206, excuse me, 2226. Now, if you had to figure out the tax, the simple thing would be to do is subtract the total cost, which is 22.26, minus 21, and you get $1.26 of tax. But it didn't ask for that. Some problems will. All right, now let's look at this problem. It's a little different than the last one. This time it says you purchase an item and the total cost including tax is $45.63. So the last problem we knew the price before the tax, now we know the price after the tax. This time the local sales tax rate is 6.4%. What was the price before the tax? And then what was the tax amount? Well, once again, tax is 6.4% added on. So if I add 6.4% to 100, oops, that's a typo there. It should be 106.4 right there, excuse me. It's 106.4% of, okay? So remember, tax is tacked on, I add it to the 100% and it's of, and then I can use my formula. So this time, it's the 1.064, remember 106.4, excuse the typo, move the decimal over 2 spots, is 1.064, times the price that we do not know. This is the price tag price, gives us the result of the price after tax, which is $45.63. So this is different from the last problem where we took the 1.06 times the price that we knew. Now we're taking 1.064 times the price that we don't know to get the result value. To solve the price, you just divide, and the price is 45.63 divided by 1.064. Rounded to the nearest cent, we get 42.89 as a pre-sales tax price. To figure out the tax, you just do a simple subtraction of the price including tax minus the price before tax to get a tax of $2.74. Alright, now I'm going to solve a couple of those problems that were listed at the beginning. It says the first one was a total of 13,000 newspaper employees. 2.6% of the newspaper workforce lost their jobs. How many employees are in the newspaper workforce? So we know that 13,000 people lost their jobs, and that's 2.6% of the total workforce. Okay, so the problem already uses the word of. I don't have to add 100 or subtract 100, or sorry, subtract 2.6 from 100. So it already has of. But the main thing is where is this 13,000 going to go? Is it going to go in the original value or is it going to go in the compared value? Well, here's the thing. It says 2.6% of the newspaper workforce lost their job. We don't know that number. We know the number of people who lost their jobs. We don't know the number in the newspaper workforce. So we're going to see that the percent, 2.6% as a decimal, is 0.026. If I move that decimal 2 spots and get a 0 in front of the 2. 2.6% of the total workforce, which I do not know, gives me the result of 13,000 people that lost their jobs. So to solve for this, we got to divide again by 0.026 and get 500,000 employees. So there's a big group of newspaper employee workforce, 500,000. When 2.6% of them lost their job, that resulted in 13,000 people that lost their job. So we went back and found the original number of employees on the newspaper workforce. Okay, last one. Citigroup stock fell 15% last week to $44.25. What was the stock value before the fall? Well, 15% fall is the same thing as a decrease of 15%. So when we have that, that's not a percent of, okay? So the fall is a decrease. So 100 minus the 15% is 85% of the original value. So if you fall 15%, you're 85% of what you used to be. Of, keyword. So using the formula. Now, the 44.25, does it go in the original value or the result value? Well, 44.25 is the result of the 85% or the 15% fall. We don't know that value before the fall. So we're 85% of what we used to be to get 44.25. Solve that again, you divide by 0.85, and we get a value before the fall, 52.06. Alright, so that's the end of the first half of the lecture. If you want to go back and watch any of these examples, that's the great thing about having a video. Good luck.